Hello and welcome. Thank you for joining today's webinar. We're ready to get going. So my name is Manish Taylor. I've been at New Relic for about 4 years now. Prior to that, spent many years developing various applications in banks and in the monitoring space as well. Today we have David on the chat, who you've just heard doing the introduction as well. He's on the GoTo webinar chat forum, where you've got a questions panel as well. Anything you've got along the way, pop that in there. If you have any technical issues, David should also be able to help you on that. So today we're going to spend, I don't think it will take up the entire hour, but we're going to be talking about the open banking initiative. We'll start with looking at it from a customer's perspective and how banks are dealing with this as an opportunity, and also the challenges and the barriers they have to overcome in delivering what is the requirement today. And we'll also be going through a bit of a technical demonstration on how we have partnered with companies, the approach we've taken, the value customers have got from a technical perspective. So before we dig into open banking itself, let's think about this from a customer's perspective. We don't, as users of banking services, we don't wake up in the morning and think that we need open banking or even a bank. And as technologists, as technologists in this space, we often think of things as projects, timelines, deliverables, and we often forget what it's like as a customer and what this is going to bring to them. So I'm going to show you a quick little video on how open banking is going to affect a customer.
Alexa, what's my bank balance?
You have £3,965 in the account, but tomorrow your mortgage payment will be taken out and you will have £1,570 remaining.
All right, so that was a pretty good experience, I would say. As a user, I want to check my balance, pay a bill. I need to have enough money left over for all those other things that I want to do. If I can just talk to my device, that would be a pretty satisfying experience. Let's take a look at a slightly different scenario.
Alexa, what's my bank balance?
I'm sorry, there is a problem communicating with your bank. Let me try again. I'm sorry, it seems your bank is not responding at the moment. Would you like me to wait?
Yes, please.
Did you know that your bank's responses are 30% slower than the national average? Bank of NewTek provides responses 20% faster than the average and much more. Would you like me to tell you more?
Yes, please.
Bank of NewTek are providing a £100 credit for welcoming you, and you would receive an extra £115 over the course of the year in interest payments based on the average savings you have in your account. The mobile application has a 5-star rating for both your Android and Apple devices and covers all the products and services that you use. Would you like more information?
Yes, please.
I have checked with Bank of NewTek, and you meet the criteria and have passed their eligibility checks. I can move all your incoming and outgoing payments, move your outstanding balance, and close your old account next week, Wednesday, and you won't have to do anything. If you would like to take up this offer, please confirm by saying, Alexa, please move my banking to Bank of NewTek.
Alexa, please move my banking to Bank of NewTek.
All right, so quite a different scenario. The end result for the customer is the same. The guy still got his thumbs up. He was still able to do all the things he needed to do. Everything is about the consumer, and the consumer getting a good service regulates driving towards that, and the result will be the same. The change, the difference in the two scenarios was actually the bank. It was the institution that loses out. When things don't work properly. And this is not a made up scenario or scaremongering or fictitious story here. The technology today in open banking, this is exactly what it's about. It's about creating competition and enabling the customer to get a better service. You may have noticed in the middle of that diagram there was that little switch guarantee symbol. That's been around for many, many years. September 2013, that was mandated in the UK, and this allows you to walk into a new bank and give them all your details and switch across to a new banking service without ever having to speak to your old bank. Some people have used it, some people haven't. So the competition aspect has been there already for some time. So the question is, what is open banking, and how is this going to change further? So there's lots of different definitions. I chose one from Wikipedia. It seems good enough. Open banking is a financial services term for the use of open APIs that enable third-party developers to build an application and service around financial institutions. So what happened in the background is that the UK government's Competition and Markets Authority has been looking at ways for new services to be provided and new service providers to enter the market, encourage development of new financial products, and offer the customers more choice. When they looked at that, they concluded that there just needed to be more competition in the market. The large incumbent UK banks didn't have to compete hard enough for customers' business, and they made it very difficult for new entrants to make it into the market, to grow and to compete. So open banking was introduced to change the status quo, increase competition, and the efficiency that things can take place, as well as stimulating innovation in the market. It allows this by having third parties allowed to have access to customer data, which is currently held by the big banks, and requiring these large organizations to make this data shareable in a secure and standardized form to these registered third parties. Therefore, the APIs will empower customers to instruct their bank to send money or access their personal data or initiate a payment on their behalf directly with the banks. So if you think about that video just now, Amazon will be able to make a payment on your behalf via your current banking provider. Okay, that's exactly the scenario. And so the promise is really to level the playing field and allow development and personalization propositions to come to the market, and encourage people to switch and get more competition in the market in a cheap and efficient way. So all that is really good from a customer perspective, and all of us as banking customers, that's fantastic news. But from a bank's perspective, or a provider of these services, these are big changes, and change always has risk. And if you look at some of the statistics, bankers today are thinking this will negatively impact their business. The fear is that customers, they will lose that touch point with their customers. You become a background piece of plumbing rather than what the customer is engaging with. That may be true, but there are also other challenges as well. These new APIs that are having to be created, no institution yet knows what the rate of adoption is likely to be. How fast will they get adopted? How much strain will they be put under? So the required scale is unknown. The transaction volumes will also change. Banks have built a business and understand their profile of how often people engage with their current banking products or even their mobile applications. But if these third parties start hitting these endpoints, making smaller, more regular interaction points, how will that scale? There are also very stringent timescales provided by the regulators as well. So there are very tight deadlines over the coming years on what has to be provided. And the regulators are changing from requiring very business-specific KPIs, such as how much equity an organization has to hold, or how much client money has to be kept in a secure place, to being enforcing, in effect, technology KPIs as well, and providing fines if they are not met. And finally, the big change is that the regulation will provide what is the underlying requirement is more competition, bigger competition, newer competition that doesn't have the legacy behind the scenes as well. And so how do financial services organizations, with their typically very risk-averse nature, manage to keep up with the change, which requires a much faster pace of change? How do they keep up with the tech-savvy regulators? How do you deal with the legacy that's already in play at the moment and adopt new methods of building software faster? So this all sounds very much like doom and gloom. Sounds very problematic, and yeah, nothing good there from a bank's perspective. But some recent survey, or a YouGov survey, they asked customers, or they asked the UK population, if there was a new consolidated banking app, and by that they mean a single mobile application that would allow you to see your bank balance across multiple accounts, multiple providers. They asked this audience, who would they use most if this service was available? And as you can see from the statistics, the idea of using one of these aggregation services from a new startup bank like a Monzo or a Sterling, or even one from a big provider like an Amazon or a Google or any other tech company, is actually quite low. People will most likely to use this service if their current traditional bank was to offer this. And that's a big telltale sign, in that there is a huge loyalty factor in the audience that are using the banks today. We trust our own banks. We go to our own banks for, you know, all the different services that we require, and we'd rather stick with them if they're able to offer the service that they promised they should. With that in mind, the flip side is that our expectations are pretty high, and you know, the tolerance is quite low. So another question from the same YouGov survey was, what would cause people to stop using their current mobile banking application or move to a different bank or different channel? And you can see here that it wasn't so much about new features. It wasn't that if a bank bought out XY functionality or used the latest technology such as fingerprint recognition or eye recognition or any of that cool stuff. It's that the app has to function correctly. If the app was down frequently, or a payment fails, or there is a timeout occurring within the mobile application, these are the frustrations that would cause somebody to move away to a different provider. So in summary, I think what that shows is that change is afoot. Things are being mandated in the market. It's an exciting but also challenging time. The most important thing, and the quote here from Gene Kim, is agility and speed are the key attributes for any company that want to win in the marketplace. So in effect, whether you win or lose in the space today will be determined by your ability to move fast. Everything in the world is moving faster, and you need to allow your teams to innovate, learn, adapt, scale, and deploy at the rate that it's going to allow you to keep ahead of the rest. And so we're going to jump now into how are we helping customers? What are we doing? What are we seeing in the space? And what are customers doing to deliver on this promise and make the best out of the opportunity that lies ahead of them? The first thing to kind of level set or to understand is that open banking isn't just a new application that banks are delivering. It isn't just a new piece of functionality they can either buy off a vendor in the market or have one team delivering out to the customer base. It has a very large dependency upon all the services and the functionality and the systems that are already in place today. And this is causing a big shift in terms of what technology, platform, and architecture customers are delivering today. And when I talk about customers in this sense, these are the institutions, the banks. So if we look historically, we had big monoliths sitting on old HPUX or mainframe systems in the background, and a very traditional waterfall approach. This was slow, this was costly, but it existed, and this is what allowed applications to exist so many years ago. And as time's gone on, organizations have had to look at more cost-effective or cost-optimized ways of delivering services and technology. And so we moved into Windows and Linux and VMs and containerization as you move along this horizontal axis. At the same time, there's been a big shift in the way software is being built. So moving from those long cycles and waterfall models to more API-driven approaches, more sprints, smaller teams, DevOps, all the way to the top where each team in a polyglot architecture can go off and develop applications written in different languages which suit the service with the best fit and the skill set that you have within your organization. So as we move along these two axes, you see that applications become smaller and smaller in size, moving into these kind of microservices, smaller components, and you may even eventually, maybe your organization is today, moving towards using either internal or public clouds where you don't care so much about the infrastructure. You're just looking at delivering the services with the velocity that's required at the most cost optimal way. Again, thinking back to how do you scale these services? You don't know what the scale is going to be. How do you know that they're going to stay performant, or you could get fined by the regulators? So keeping this in mind, most organizations have moved down a very similar approach in terms of how they are structuring and architecting their platforms. And with a very overly simplified diagram, over on the left-hand side here, you get to see that a lot of the legacy technology stack still remains in place. And legacy may be Windows or Red Hat boxes, old AIX machines, could be as old as mainframe systems. Some of this is going to stay in existence. Maybe a lot of it is going to stay in existence. But the rate at which this can be changed can't impact the rate at which these new APIs or mobile services or any other channel can be delivered. And so on top of this, most organizations are implementing various internal platforms, whether this be built on vendor-based platforms such as Pivotal or OpenShift, or using a Kubernetes stack under the hood or a Mesos, creating a more microservice dynamic platform that will allow these development teams to deliver new services quickly and efficiently. And these platforms create the API layer to break apart the linkage between what you're developing on the front end here and the legacy technology in the back end. And eventually, you are delivering more and more services in this API stack, having less and less reliance on this legacy tier, and therefore the dependency on that stack and the rate at which that can be changed doesn't cause a burden anymore in the future. So that seems to be the main stack, the main flow, the main architecture that people are progressing down the path of. And when we work with customers on this journey, it's very important to understand that what tools they require here versus what tooling solutions and methods of working they require here are very, very different. And it comes down to three really fundamental capabilities that are going to allow you to move fast, and more importantly, move fast with confidence. Moving fast in the wrong direction or always worrying about what you're delivering is not the way to go about things. So moving fast with confidence is a key aspect here. And there are three components that New Relic relates to here. One is observability. Understanding what's going on within your environment completely and fully, allowing you to find and fix problems quickly is key. The other thing is adaptability. Having that data and then never looking at it again or making a decision and continuing down that until you've reached the end goal is also not possible for any business today, especially delivering on these new requirements. Having the data, having that fast feedback loop to your teams to make decisions, use the data to make the next decision is key. So adaptability. And finally, as you move into these smaller microservices, more teams, different development bases, different code bases, you have to have all of your teams aligned on what's important and sharing that data. No longer do you hear of an organization being a .NET shop where everything goes through a single funnel and everyone is aligned from that perspective. Data has to be used to create alignment. And that's a key factor. Observe, adapt, align, and having that information with the right person, with the right team to make an informed decision using that information. So whether it be your product manager who has a goal to attain on certain KPIs, or whether it be a developer who is solving a problem trying to fix either a bug or a performance issue, or all the way up to your executive who's got an idea on how this new business initiative is going to make the company money. All of those need that right level of insight and data to be able to adapt and make their ongoing forward-looking decisions and take action. So, given that context, I'd like to jump into the technical part of the presentation now and show you how New Relic is being used by customers in this space, and how they align to these three different pillars. So I'm just going to switch over into my browser. So New Relic is a SaaS-based solution. Everything is accessed online via the portal or via APIs as well, which is what we're talking about. I'm going to talk to you mostly about the UI and how the data coming from your applications is represented within New Relic. But as I said, a lot of this data is available, or most of it, all of it is available via APIs as well. So you can use it as a part of your stack. So you have all these new APIs. You've got to deliver things like a payments API, deliver an API that will allow a third party to check a user's account for various transactions or make a payment on their behalf, or check where certain services are available for a customer. Each one of these services is vitally important that it's performing, it's scaling, it's available, both for your customer satisfaction, but also to ensure that you're not going to get any fines or repercussions because of what the regulators are demanding. One of the views that New Relic has will allow you to see each one of these API endpoints in a very easy to understand RAG status, green, amber, and red across the left-hand side of this view. Each one of those APIs has a throughput, a call count, an error rate. Okay, so how are they trending? And you can set different performance measures for each one of those, or all of those the same if you wanted to. So there's one view of the data. Another view of the data is to look at this more from a technology or a graphical standpoint. We call this a service map. This allows us to see each one of these components, whether they be an API endpoint or a service, and we can see how the linkage between these change and adapt. So how does one application call another one, and see the downstream flow? Again, in a RAG status perspective, we've got some .NET apps, we've got some Java apps, we've got some Python, Ruby, whatever the applications are. We can see from a RAG status perspective, what is a dependency, what is the flow of messages going through them. Now, obviously, these dashboards, when you start to move into these service level views, can be quite hairy. New Relic does allow you to zoom in, and you can create little views of the ones that are most interesting to you, of course. There's different ways of viewing that data. Another view is to understand how transactions are traversing through your system. So each time a user or a third party makes a payment, requests a payment, looks at some transactional data, that should respond in some parameters in terms of timing and availability. You do not want your service to have that Alexa response to your user to say that the bank isn't responding. This particular chart allows us to very quickly see how each one of those transactions is traversing through that system. And it's not just a request response. That transaction has to navigate through multiple microservices all the way down to some tier in the background before the customer gets the response they require. Here, New Relic allows you to select one of those dots and we can drill into one of those traces in infinite amount of detail. You can see when that transaction request came in, how long it took to respond, and all the systems and services that it had to traverse through in order for that to be a successful transaction, a successful response. You're delivering on the promise of what the API was allowing the user to do. And at each one of these stages, regardless of how many there are, you can drill in and get more detail around what was taking time, where was it slow, what's changed, how is that API being stretched in its capacity or scale or size due to the amount of throughput that's coming through, and drill into an individual transaction to see what the impact is on the system. When we drill into an individual, so just one of those tiny little bars that we saw on the last screen, there is again a huge amount of data that New Relic collects about that service. So now we're within one particular service. We saw that service as just one step on that last screen. Now we can see within this time window how much time is that code taking running in that Ruby layer. Java, Go, doesn't really matter. This particular service is written in Ruby. How much time is spent in the middleware? How much time is being spent in the database? And how has that time varied as the throughput has changed? It's no good your service slowing down and responding badly when the throughput starts to increase. And again, we'll look at some scalability aspects a bit later on. Error rate being 0, fantastic. Nice, smiley, happy green face, brilliant. If there wasn't one, if there was a red face over here or an amber face, we will have the data, we'll have the chart to be able to drill into what's problematic. We can quickly identify, is it just particular types of transactions, particular types of endpoints, particular requests that are running slowly? And if they are running slowly, is that the cause of something within the code, or is that something that's problematic on the application layer? Sorry, the infrastructure layer. We will dig into both of these avenues in just a moment. So we can see the 6 hosts that this application is running in, and we do have some slow requests. We have some transactions which are taking 2 seconds. Again, go back to that example of there's someone asking their Amazon device for their bank balance. 2 seconds may not seem a long time here, but if you add all those steps in that flow together, that adds up to an aggregate number of maybe 5 seconds, and 5-10 seconds is a very long time when you're waiting for your bank balance to be responded to. So we can drill into that 2-second transaction. We've got the 2-second transaction here. We can see very, very quickly that nearly 100% of the time of this one transaction is spent within this MySQL statement. If that's not enough, we can drill into the stack trace of the code, and New Relic is automatically folded up. Here, there's lots of code you don't really need to be interested in. The thing that's taking time are these 2 calls to the database, and we can see the query that's being run, and it shows the explain plan. You may recall you saw something very similar in that trace that we saw going across all the applications. So New Relic has, from multiple directions, pointed us to the same area of code that may need some attention. And that's a very powerful piece of data or observability to have at your fingertips in a quick, easy to access and understand manner. Now, I mentioned earlier that this application obviously runs on some infrastructure. So if it's not a code level issue, then we want to understand, I've got my one application here. We've got hundreds of applications in this account, but there's one application we've drilled down to. This application is running on 6 hosts, and we can see that host level information. We can see how those key KPIs are performing. And again, because the data is there in such a raw format, but also in a nice, intuitive, easy to use UI, we can start to drill down on these things. Maybe we're interested in understanding on these hosts which processes are running. So now on these 6 hosts, which have got this one application running, there's all these different processes. I could stop grouping this by hosts and group it by processes, which is probably going to make this a bit easier to understand or see. So on these 6 boxes, I have hundreds and hundreds of processes that are running. Some Java, some Node, some sleep processes, lots of different things running. Some of these may also be running in containers. We talked about that platform either using Kubernetes or Pivotal or OpenShift or something else. New Relic has that data in the background, so I can say, just show me all the processes that are contained within a container. And so now I can get very quick visibility of that. I may be interested in understanding which container is having the is consuming the most amount of CPU. So I can drill down on that, flip that the opposite way, look at that container, filter down on it. And then maybe I want to understand which hosts have got that same container running on there. I can group that. So this particular container is running on just 2 of these hosts. However you want to dissect the data, run into the details of it, whether it be at the code level, whether it be at the application level, database level, the point is here that we've gone all the way from the very top of understanding the API you have to deliver and the service levels down to a piece of code or a piece of kit that you are responsible for or may have an effect on the application. Now that kit, that box, which used to be AIX, it used to be mainframe, modernized to a Linux machine or a new container. You may even be using cloud services, as I mentioned, or thinking about using them or building some new service. As you build these new APIs that have to scale to infinite sizes or unknown endpoints or end scales, a lot of customers are looking at things like AWS or Azure or Google Cloud Platform. New Relic also has the ability to hook into each one of these providers and draw out the relevant data, whether that be about things like the EC2 instances, so if you're using EC2, or you may be using serverless functions like Lambda. New Relic will connect up to your cloud provider's accounts and draw that data in. So if we click into some of these dashboards over here, we can see in AWS how many EC2 instances, what are the different instance types, what is the performance, what is the configuration that's going into these environments. If you're using Lambda functions, how well are they performing? Is the response time as they are expected to be? Are they above or below some kind of threshold? Are you calling enough instances and is the APIs being invocated enough, or are you having bottlenecks, errors, problems occurring within your stack? Same thing is true within the Google Cloud Platform, the app engines, how many are there? What are the response times, latencies, so on and so forth. There's a lot of very granular data available provided from your app, your code, regardless of which infrastructure or technology it's sitting on. Now, all of this data is also accessible via our Insights UI. So this same chart about this GCP app engine is the same chart that you're seeing here. We can just simply click on this and view the query. This is what query is being run, and if I click on View Insights, you see that chart being created over here. The point I'm trying to make is that all of this data, code-based, infrastructure-based, service-based, is all available in our data store, which is called Insights. And you as a user are able to query that in an infinitely possible amount of ways. So as a simple query, I could say, I want to do a select. I want to count how many, and you can see it's very nice, easy to use UI. I just want to count the number of transactions that my service has received from its end users within the last 60 minutes. So in this demo, 153,000 within the last 60 minutes. Let's do that since 1 day ago. So we've had 4.5 million over the last day. Let's compare that with the same day last week. Now we've got a 2.23% drop off. When was that drop off? Okay, it's been very similar. The day overall has had the same number of requests, running through today, same as last week. And maybe I want to facet that by something technical, maybe the HTTP response code. So how many transactions have had failures and how many have gone through correctly? So we can view this using different graphical representations. We can query this and make this as complex or as simple as we like. And using the UI, we can see what queries are being created. And finally, we can simply add these to dashboards. Click on a button and you'll get added to a dashboard of your choice. This allows us to have, and I'm going to show you some finished dashboards later on, but hopefully what you agree with and what you've seen in that demo is that New Relic has a very deep level of instrumentation into all your technology. And therefore, we have the observability required to give you the confidence about, what systems need to be fixed, where problems can be found, how things need to be run. Just checking on there. Okay, on the time. Right. So that's observability. The next thing we're going to touch on is adaptability. It's no good having data which you don't use on a regular basis or every day or when you're making decisions. So adaptability is all about taking that data and providing it to the right people very quickly such that you can make the right informed decisions and move faster. The first example of where this can be seen is within our deployments functionality within New Relic. So every time each one of these services that you're delivering or APIs that you are publishing has a change, you need to understand quickly whether that change is having the right intended effect or not. New Relic keeps a chronological timeline of when those deployments are being made, who is making the deployment, and some key KPIs around whether that performance is moving in the right direction or not. Each one of these you can drill down into very quickly and see some more detail. So the gray line here represents when that deployment was made, and we've got the time horizon across the bottom for key KPIs such as response time and throughput, CPU, physical memory, the end user experience, the AppDex score as we call it, and the error rate. Very quickly we can see what the performance was like, or the throughput and the response time was like leading up to the deployment and what it was like afterwards. Potentially here there was a problem and therefore a deployment had to be made, or maybe there were, and I think that's the case here because it was a good an hour before the deployment was made, there was some problems occurring. A deployment was made, and if things were fixed afterwards. Ideally, we would like to probably see something more along the lines of things were working fine. You're making a deployment for making an improvement. We can see the change log and the change report if we wanted to. And what you would expect to see is maybe the response time drop, the throughput go up. You want the error rate to stay either consistent or drop off. You can check that the change that you're intending to make is being made and having the net effect, the desirable effect. And all of this data is also available via Insights. So I showed you earlier that Insights query. This is the same tool. It's no different. You can see here a query looking at the build numbers. That's how you create the dashboard, and we get an end result which is showing us how many builds, what is the status of those builds, are there more successes or more failures recently, who's checking in code, how many problems have we got in the latest commit that's being driven out of this dashboard. Code commits, failed builds versus previous successful builds, how long it's taking to resolve events, who's resolving the most number of events, or who's checking in the most amount of code. The statistics here are allowing your team to have the visibility that they require and make sure that the coordinated activities that are occurring are also being measured and data driven, and again using that to make sure you're moving faster, confidently and quickly to make the changes that are required. So that's what we class as adaptability. And the final thing is all these new teams that are being created. How do you leverage all of them? How do you get your teams to be smarter, better, and in sync, such that you're having the biggest impact while you're all running, possibly, not in separate directions, but running in parallel. Again, we go back to the APM screen over here. This is one view of the world. We had details of that particular service, how much time is taking this time in a .NET application versus other things it's dependent upon. While we could drill down into the code, we can drill down into the error rate, and we can drill down into the infrastructure. Maybe another view of the data is looking at which endpoints we are hitting. So each one of those APIs may have a different version number. How are those API points, what's the throughput? What's the response time? What is the transition rate between those? And again, we can drill down. New Relic also provides you with a lot of out-of-the-box scalability analysis. So we mentioned right at the start, these new APIs, we don't know how well they're going to be used by these third parties, how many requests are going to come through. We can't block them. They're required for these third parties to do what they've been permitted to do by the users. So we have to understand our scalability of our services, our APIs very, very quickly. And New Relic will draw you some nice out-of-the-box graphs. Here's one example. We can see the the number of requests per minute going across this horizontal axis. So it's going from 5 requests per minute all the way up to 40 requests per minute. And we can see what the response time is at these different times a day. This is a pretty nice graph. Regardless of whether I got 5 requests per minute in my system or 40 requests per minute in my system, the response time to the user or to that caller of that API seems to be pretty much the same. Doesn't vary much. It's around 200, maximum 250. And what we would hope is that if the number of requests per minute jumped to 40,000, 400,000, 4 million requests per minute, we still want to be able to deliver that in a scalable and responsive manner. And again, we can dissect that via database time, infrastructure time, application time. So you can have confidence about moving that service to production and scaling that for your users. In addition to seeing how that service is scaling with your real users, you may also want to provide some ongoing API testing of your own. So New Relic allows you to choose an API. I'll just choose a couple of locations to run this from. You can run your API test from any number of public points that we provide, or you can run your own test points as well within your own infrastructure or network, and you choose how often you want to run this test. So this isn't a load test, but this is providing you with the ability to test an API to make sure you have the right answer from these different locations, and it's always available. And a simple script will allow you to tailor how you call that API, what information you provide it, and what the result is off the back of that, which means that you can get a nice view of all the different APIs. So the very first screen I showed you in the demo was the technical availability and performance of your real APIs in a list. Now here you can see all your endpoints from a synthetic perspective. Are those APIs available? Are they delivering? What is the success rate from your test that you're running from the different locations? And if we drill into some of these tests individually, we can see things like the load time, the availability. So if we've had any downtime, we can see it. And if we have any downtime or any slow responses like we see here, then we can drill into them in more detail and see which part of that flow is taking time. Is it the network? Is it the application? Is it waiting? Is there a large amount of data coming through? We can drill into that from an application perspective, or again, view it in insights and drill into the details, because all of that data, as I mentioned, sits within our data repository over here. So at the end of all that, the aggregate information is going to allow you to create dashboards that member of the team is interested in understanding. So maybe there's a developer in your team or someone in your technical team that want to understand what is the average response time of a particular API, what is the throughput, which applications are throwing errors, or if you're responsible for a particular application, which errors are the application throwing? Is it correlated to a particular infrastructure host? Do I need to go and speak to that team, or is it to do with one of the cloud providers? Is there a problem with the way my EC2 instance has been set up? Maybe I want to analyze the difference between the performance of my on-host application versus my AWS or Google Cloud Platform or Azure estate. Maybe I'm moving one of my services across. So I need to understand what was my performance like before and whether my performance has improved, degraded, or remained the same in the new state. Again, I can test those using synthetics. I can see what's happening to my real usage, and I can see how each of them are scaling alongside each other with a very detailed level of performance data. Again, behind the scenes to this, we can drill right down into the code as well. And finally, we may want to set up alerting as well. So it's all well and good having nice dashboards to look at, and they are really, really important because they're going to provide us the information and answer those questions we need to answer to move forwards and make those decisions. But an important part of our team and our organization is also the operations group. Who's going to deal with these issues when either a third party has a problem with the API, or making sure the availability is 100% such that the regulator, we're meeting the regulatory demands. So alerting within New Relic allows us to set up alerts through any part of our product, whether it be at the application level, the API level, or even based upon those queries that you ran within that insights layer. So, doing that count of the number of transactions which we had, just that simple query again. I can even set up a query based upon that, and I can see the data and look at what the thresholds are and define some kind of baseline, right, or outlier. All the UI allows you to create that. In fact, I've got an example of a baseline here. With the explosion in the number of services that you have, with the explosion in the different types of technologies and APIs that you have, it's almost impossible to define thresholds for each one of those KPIs. But once you drop a New Relic agent onto those applications, we start to collect that data and profile it in the background for you. So here is an example. This blue line is showing us what this particular metric, regardless of what the metric is, has done over the past 2 days. And it's telling me over the last 2 days, I would have had one critical violation if I keep my tolerance level at this. You see this little slider bar allows me to dictate what my tolerance threshold is, or band is, around that blue metric. So if I widen this out, then clearly I'm not really ever going to be woken up if this metric runs in the profile that it's been running over the last 2 days. And if I don't want to be woken up, that's probably quite a good band to put it around. But maybe I want some warnings more often. These little blips may be of concern to me and something I want to have a look at, therefore keep tabs on. So I can create another funnel around it, and hopefully it comes across on the screen. There are 2 colored bands, the darker and the lighter gray. Sorry, the darker gray is the warning threshold, and the lighter gray is the critical threshold. And so I can create bands, create alerts based upon any of the data that I've collected in my UI. And I can choose how I get alerted, either a Slack message or an email, or firing a message out via PagerDuty for an operations flow management service. And I think that will then culminate in the end dashboard that I want to show you here, which is you can aggregate any of the data that you're interested in understanding and create metrics on that. So if it is an executive who wants to understand, is the API that you're delivering accessing more current account information versus credit card or loan information? Which applications are causing the most variation in terms of the response time that the third parties are seeing? Or maybe your own teams are leveraging those APIs to deliver new services within your bank. What is the conversion ratio? What is that business KPI that you're driving toward to enable you to deliver new services? All of that is possible within the New Relic UI. And so hopefully you will agree. The final box there in terms of alignment is complete, and we allow your teams to collaborate quickly, easily, and efficiently to make the best use of the data that we have. I'm just going to switch back to the presentation. 3 ticks. Ticks are always good. And so in conclusion, we started out by saying that there were some key challenges. Challenges are that the new regulations and increased competition are creating unforeseen pressures. Things are moving fast. Things that are moving fast are now unknown as well. We don't know how these APIs are going to scale, how they're going to get leveraged, what new competition is going to come into the market. And so in order to stay ahead, in order to deliver on the promises that are being made by this open banking demand, is you need to have good observability. You need to be able to see everything. And only when you've got access to all of that data can you use it to make informed decisions and make those decisions quickly and with confidence. And you want all of your teams to be able to use that data to move forwards fast and create high-performing teams. So at New Relic, we've been doing this for well over, I think it's over 10 years now. And we've worked with some of the most innovative startup organizations and largest enterprises. We definitely adhere to that new modern software culture stack. We use a very customer-centric data platform. That means that you're not just looking at logs or infrastructure events, but you have perspective on all of that data together. And it's a tool that is built and deployed for entire teams. We focus on the ease of use and getting your data aligned such that you can trust it and move faster with confidence. So with that, I'm going to ask if there are any questions, and I'm just going to look in this chat room. In fact, we're quite short on time as well, so it took a little bit longer than I thought. Luckily for me, there are no questions. And as the hour is up, I'd like to say, please do feel free to reach out. You have my contact details here. Get in touch. We're here to help. We love hearing customers' success stories, and we get those by them using our software, but their journey starts somewhere, right? You can download our tool and use it in isolation. You don't have to contact us, but if you do, we love working and engaging with our customers to help them along this journey. Thank you very much for joining, and hopefully this has been useful. Bye-bye.